Hey everyone. In today's video, we're going to take a look at how to graph a linear inequality, specifically looking today at inequalities that are in slope-intercept form. Okay, so a couple of general rules that apply to graphing any linear inequality. We're going to graph the line just like we would if it was a linear equation. So slope-intercept form, we're going to have a y-intercept, we're going to have a slope, and we're going to use those to graph our line. A couple of slight differences between inequalities and equations. With inequalities, we're either going to have a solid or a dashed line, and that is based on whether it is an equal to or not. Okay, so if it has the line underneath, that means that it is a solid line. Okay, if it does not have the line underneath, that means it's going to be dashed, because dash would mean that our dashed line is not part of our solution set. Okay, we're also going to be shading on one side or another of our inequality, again, because an inequality represents all of these solutions greater than or less than the linear equation that we are graphing. So we're going to be shading, and again, I'll show you how to test for a point to see which side we are going to be shading on our line. So let's take a look at how to do that. Okay, so here we have the linear inequality. Y is less than or equal to negative 1/2 x plus 3. Okay, so again, we know how to graph this. Okay, first off, we see that it has the equal to, so it is going to be a solid line here. Okay, so our starting point is positive 3, so I'm going to go to positive 3 as our starting point, and my slope here is negative 1 over 2, so that means I'm going to go down 1 and to the right 2. So far, there is really no difference here as far as how I graphed it, right? It has a solid line, again, because it has the equal to. Okay, now here we want to go ahead and test to see whether we are going to be shading everything underneath or everything above. Okay, I do that by testing a point to see if it's a solution or not. So I'm going to use the origin, which is a very easy point to test. So let's go ahead and test the origin to see if it's a solution. So the origin we know is 0, 0. That's going to be our x and y, our point to test. Okay, so we get 0 less than or equal to negative 1/2 times 0 plus 3. And we ask ourselves, is 0 less than 3? That's the solution that I got. 0 is indeed less than 3. Okay, what that means is that we are shading on the same side of the point that we checked. Okay, because it is a solution. Okay, if this was not a solution, that means that I would shade on the opposite side of where our point is. Also here, if it's in slope-intercept form, it's easy to tell. Less than means it's a less than. That means we would shade underneath our point. Our line. We'd be shading underneath because it's a less than. Let's take a look at another one. Okay, so y is greater than negative 4x. Okay, now this one, our starting point, we don't have one, right? So we know that it's a plus 0. Okay, that's going to be our y. Okay, so my y-intercept is 0. Now here we notice it's going to be a dashed line because it does not have the line underneath. Okay, so greater than negative 4x. Okay, so negative 4 is negative 4 over 1, so I go down 1, 2, 3, 4, and to the right 1, and I can go ahead and graph that. Now we know that it's dashed. So actually, let me do it this way. Okay, so that's going to be a dashed line, again, because we don't have our equal to. All right, and now we have to test a point. Now, in the first one, it was easy to test because we did not have our line on the origin. In this one, our line goes through the origin. So here, we're going to pick another point to test. Let's pick like 1, 1 would work. You can pick any point. It doesn't matter which one you're picking as long as it's clearly on one side or the other of our linear inequality. Okay, so if I test the point 1 and 1, we're checking to see if this is a solution. I get 1 is greater than negative 4. Okay, is 1 greater than negative 4? Yes, it is. Okay, so that means that I'm shading on the same side as our point again, because this is a solution. Again, if it was not a solution, you would shade on the opposite side. Okay, and again, you see greater than negative 4x, which means greater than. You see that I shaded in the greater than section here. Okay, so those are some general rules for graphing linear inequalities.